We haven't done a problem with a definite integral yet, so let's do one, because of course usually the reason you're finding an antiderivative is so you can calculate a definite integral using the fundamental theorem of calculus. Also, just wanted to point out that in this case we have an exponential function, and usually when you're looking for the inside part of the function, it's going to be the exponent when you have e to the something. So in this case, we have e to the x squared, and it's usually going to be a good choice to say that u equals x squared because we're going to choose the exponent. Once again, this is not a hard and fast rule. It's just a guide that often works. So say that du is equal to 2x dx. So you can easily see here that this part is e to the u, and this part here is going to be du. So our integral is going to equal the integral of e to the u du. This almost looks too simple at this point, but I'm trying to make another point that's very important. Many students are going to write here, they're going to write 2 and 3 and say, oh, just sort of mechanically copy those limits of integration over. But that's actually incorrect to do. The reason it's incorrect is that we've changed the variable to u, which means that we actually have to change all the numbers in the problem to values of u. So since the entire integral is now in u, and u is equal to x squared, these were values of x, and we now have to plug them into the expression for u and change them to values of u. So I'm going to square the 2, getting 4, and I'll square the 3, getting 9. This is now a correct expression. So we know that the antiderivative of e to the u is just e to the u, so this is going to be e to the u, and we're going to let it go from 4 to 9, so that gives us e to the 9 minus e to the 4. Oh, and by the way, another common mistake that a lot of students make is a lot of people will write e to the 9 minus e to the 4 plus c, like as if plus c is just some magical incantation that that math teachers like to see. But of course, this is very, very wrong. Plus c, once again, that is just used to represent the fact that you're finding a family of antiderivatives. Once you actually use the antiderivative to calculate a definite integral, there is no c. You just have numbers. So the correct answer is e to the 9 minus e to the 4th.